Parallelism in Software with Jeremy Miller.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to just be really great. And my architect forums are going strong. Quick announcement. Signups for the next session are up. If you lead a software team and are looking to collaborate with your peers around the industry, maybe you don't have a peer directly in your company because you're kind of in charge of the team and you'd like to collaborate with others in your same type of role, then sign up at the link in the show notes. And also for those looking for Programming with Palermo, my video podcast, you can just search in any of the podcast directories and you'll be able to find it. Now, my guest today on the show is Jeremy Miller. He started his career as a quote, real engineer, but he wandered into software because that looked like more fun. And since then, Jeremy's worked in and led software development teams in the computer manufacturing industry, finance industry, healthcare, banking, lots of different places. And lately, he's been focused on leading software architecture teams and helping mentor other software architects. And he's had roles both as in-house architect as well as a software consultant. And he has a great deal of insight into the challenges that confront companies developing and maintaining enterprise systems over time. Jeremy is well known for his open source software tools, starting with StructureMap and continuing all the way to today to the tool Marten and Wolverine. And he's also a frequent author and technical speaker at software conferences. And he's recently helped found JasperFx Software to build a sustainable business around the Critter Stack tools. And so, Jeremy, welcome to the show. How are you, sir?
I'm doing really well, Jeffrey. And I guess I'm really sorry for making the bio so long that you're going to read it out. And you also missed the part where we're former colleagues.
Well, I was going to ask you about your kind of background, and I was just going to let the audience know when I was 25 years old. I was 25 years old. I learned. I told you this at the KCDC conference. I learned a lot from you. I had read the books, like specifically on test-driven development. I'd read it, but I'd never actually done it well, and so. You kind of helped me along the way and putting together all the steps of continuous integration and some of the patterns of abstraction so that you really could separate out logic and make larger code bases easier to manage. And of course, your tool StructureMap was one of the more popular. It was the .NET 1.1 times, and then we moved to .NET 2. But yeah, I was 25 years old, and I was kind of learning at your knee a little bit.
That was a fun time to be around because everything agile was new. Extreme programming was still a thing. So test-driven development was new. Continuous integration was new. Steve Doney that we worked with was like one of the very first people I knew of that did what we now call DevOps. So I felt like we were pretty advanced for our time.
I remember Steve Doney. I think we benefited from some of the build script work that the Windows team had done because he was on the accessibility side of Microsoft Windows, the operating system, and he brought some build script templates and then applied it to the project, which like catapulted us forward from that perspective.
Yeah, and that was way before Terraform and Pulumi and cloud computing. We had a really slick automated deployment. It was probably decades before I worked on a shop with real DevOps people where we had something equivalent.
Yeah. Well, I like to ask every guest, whether or not I know some of the answer or not, but what are some of the high points in your career that kind of shaped you and led you to focusing on what you're doing today?
Well, sure. So the things that a couple of experiences right around the mid 2000s were real springboards for me. One, I left a mutual employer of ours that was at the time was a pure waterfall shop. Pure waterfall store procedures, pretty chaotic. And I got a chance to go work for a little while at ThoughtWorks, and this is during the early days of extreme programming. That's where Martin Fowler was.
Mm-hmm.
It was just chock full of really smart people doing all kinds of open source. So that was actually my introduction to anything to do with agile development, test-driven development, CI. Structure Map started there. Really just seeing what some of the Java-based teams. So Structure Map was loosely based, not too tightly, but it was definitely influenced by a very super early tool there called Pico Container from the Java world. That was one thing, and then that led to really, and you'll remember you were a part of this as well, when we were both part of the CodeBetter.com website.
Yep.
In the pre-Twitter days, we had these things called blogs, and most of your online communication and interaction with other developers was through longer form blogs. So those
that was social media.
It was blog comments were our conversation, and for those couple of years, I was cranking out content left and right, and just having so much fun learning as I went. But those two experiences, those were my two big springboards into the rest of my career.
Yeah. And you've always enjoyed creating open source libraries that kind of implement interesting patterns and then sharing it with people.
It's always worked out, accidentally or not, where I've enjoyed my side open source work probably a little more than my day job work.
Mm-hmm.
That's where you got to be creative. That's where you got to have full control over, hey, this is my vision. This is what I'm doing. And for whatever reason, that has always been my passion, work wise.
Yeah. Well, Structure Map is kind of like this, and then Lamar on the IOC container side, you've had I would say a rare strength to be able to imagine what a bit of code can do and think about it at the top usability layer and 10 layers down into the weeds simultaneously and have it come out well. And not many people create inversion of control containers and creating generic types just right and crawling .NET assemblies and hooking things up, because that's fairly low level code. And if you have one thing wrong, then the using code is dirt slow from a performance perspective. Do you naturally gravitate towards that kind, or you don't even think about it?
I didn't start that way, but I've done it so long now. That's something I would tell folks is doing open source tool. If you are mostly doing feature work, line of business applications, not that you should make this be your life, but doing a little bit of open source development, it will stretch your technology skills because it'll force you, just like you're saying, it'll force you into more low level development. Building a library for someone else, you'll need to care more about performance than you really should doing feature work.
Mm-hmm.
When you have when you're building a library that's always going to be in the hot path for any kind of application that's using it, you have to care about more things, or not more. It's a different type of programming. You will learn more about the underlying .NET framework or whatever runtime you're in. It's something that's worthwhile for a learning experience.
Yeah. Now you speak at a number of conferences every year. You've done it for a long time, quite a bit of speaking. But you spoke at the Kansas City Developer Conference for one, and you had a talk on concurrency and parallelism. And I think that a lot of developers think, oh, async await. Okay, there's some keywords, and I can, but they don't really know the patterns. And so I was open to ask you about that. What should What should most developers just even be aware of in that space of getting code to run or multiple instances of code to run at the same time and have it come out well?
Well, that's more than we're gonna figure out in 10, 15 minutes. I think I would worry first about the impact of concurrency on your system and start from the standpoint of shared state. Even just thinking about rows in the database, that represents some logical business concept. Are people trying to edit these at the same time? Is there any remote chance that people could? Because there's a possibility to run into deadlocks or to just get invalid code, invalid state if changes happen to be applied different ways. That's probably the very first thing you need to worry about, and that's something that's going to impact any developer who builds a system that has any amount of usage and users.
Yeah, I guess I want to back up a little bit and ask, something motivated you to put together a talk like that. What did you see out there where you said, you know what, I need to talk about this?
So apologize in advance because it's a little bit involved. One of the projects I work on is a library called Marten. It's a document database on top of Postgres, but what's probably more important is it's an event store.
Mm-hmm.
A big chunk of an event store is you're constantly appending events. That's nice, but you still need to know what is the state of the world. So you're constantly in a background thread. You are projecting these stream of data into, here's the state of the world. You're writing projected views of the world all the time, materialized views for database folks. And we redesigned that subsystem for Marten a couple of years ago to try to improve the throughput. And so we took advantage of a lot of parallelism at the time. We very, very heavily used something in .NET, the TPL Dataflow Library. It's this hidden gem from Microsoft that not enough people know about for some reasons, but it's just an awesome workhorse for parallel programming. So with the async daemon, there was a lot of fancy work we had to do to decide what could be done in parallel, what could be done with a producer-consumer pattern, what can't be together. So that by itself that kind of covered the first bit of parallelism. Then on the concurrency side, now this is where you're just worried about, are people trying to touch the same data at the same time, maybe even forcing changes to go in single file so that you get good results. So part of Marten and its critter stack partner Wolverine, that I'll plug in a minute, was a lot of protection on concurrency to be able to detect, hey, I want to apply changes to this order, this invoice, this whatever it is, but I'm assuming that my command was issued based on the idea this is against version 5 of the order. So optimistic checks of, okay, I will try to process this, but in the course of saving it, if I figure out somebody else came in right behind you or right in front of you and changed it between you issuing this command and this getting saved, we're going to reject it and give you some tools to, do you retry it? How do you send messages back? So all that work that we were doing across the critter stack, both for concurrency protections and then the optimization work on the subsystem we call the async daemon, that's the asynchronous projection machine part of it. That just kind of felt like, hey, we get to do something that was a little bit interesting here. This may be the formation of a talk that might get me into conferences, and it did.
Okay.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Let's explore. I just want to make sure people understand what Marten is. In your thinking, is that something where people should make Marten the store for their applications, or should they think of it as, oh, when I need versioned data, I add that to my application? How should they think about it?
Okay, so Marten comes in two pieces, two parts, but they do work together. So originally, it was it was a library that allows you to use Postgres as a document database. So I actually built it before Cosmos. So your listeners, if you're familiar with Cosmos DB or DynamoDB in the AWS world, or Couchbase. So Marten can allow you to use Postgres that way. The event store part of it, so using event sourcing. As a persistence pattern, I would say any application where you have a lot of workflow, where you're thinking more about what are my transitions between states rather than pure state. Any kind of system where you have temporal querying needs, like building a telehealth system, where you may want to go back and say, what did the world look like at 3 p.m. yesterday? And rewind back to, well, these were the patients on deck. This is who we had. Those places, an event sourcing persistence pattern can be really helpful. Marten itself can be a little bit flexible because you're building on top of Postgres itself. So in one application, one database server, you have the event sourcing part of it, which projects to a document database. The document database stuff is useful. And as necessary, or where you need it, you can also use pure relational tables inside of Postgres for reporting, or just any place where relational database is, frankly, a better approach anyway.
Okay. And the other piece, was there a second piece to it, or was that it?
Document database and the event sourcing are like the two big pieces of Marten.
Gotcha. Okay. If people are trying to look up patterns, is there a named pattern that kind of governs how you like to implement the parallelism, or did you have to invent an approach?
So the one pattern we definitely use the daemon, it's something that's called the producer consumer pattern. Roughly, if you have some kind of resource or some kind of action that either has to be done in an exact order, so taking the event sourcing and projections, you have to process the events in the exact right order. Yeah. And we do it a batch at a time. So let's say I'm always doing a page of 1,000 events at a time, but you really need to do those exactly in order. So the actual projection part of things, that can only be happening sequentially. But there's a lot of work ahead of time that can be done to kind of prepare for it. Just knowing, hey, the event store is at this current sequence is 1 million. So you can be fetching data from the database, getting the raw events ready. So pulling it from the database, deserializing the JSON. There's some expensive work to just kind of produce the work that the projection consumer needs. It's a little more complicated. The Marten piece is more complicated than that, but the producer part is working in one set of threads, can be getting work ready for a consumer thread to ingest. Another example from my consulting lifetime, working for a very large bank where they needed to interact with a third-party web service. For whatever reason, again, transmitting transactions, you did need to do things sequentially. On top of that, the third-party web service couldn't really handle concurrency at all. So you could really only do one thing at a time. But at the same time, it was very expensive to build up all the activity, the pre-validation, building up the XML request. That was pretty expensive leading up to it. And on the back end, you had to do some extra work to finish off the transactions. So I have this activity in the middle of invoking this web service where I can only do it one at a time. I have to do it exactly in order, but there's a lot of expensive work around it. So having one, think of it really as a thread of work or a queue of work. One queue of work to producer is doing the validation, the pre-work, building up the requests, and pumping it through a queue to the consumer, which is really just a proxy of, in the slimmest operation you can, invoke the third-party product, get the results from that, pass it along to the next queue. So you're throwing data as fast as you possibly can to this web service, but no faster.
Gotcha. So we've talked quite a bit on this podcast about patterns for distributed systems, and we've had Chris Patterson from Mass Transit and Udi Dahan from In-Service Bus, and talked about queues where the producer is a process and the consumer is a different running process. Is this all of these concepts you're talking about all in memory, or do you use a separate out of memory queue for this pattern?
It could be either. So what's important here is just a logical pattern, not necessarily the mechanics. So taking Wolverine as an example, Wolverine has a lot of overlap and functionality between In-Service Bus and Chris Patterson's Mass Transit as far as communication. But it also supports local queues. So this particular consumer I'm talking about, you could just run this all in the same process, to be using local queues to be passing work, streaming work from the producer to the consumer.
Okay. So really it's a pattern, a way of thinking, and it could be all in process, or it could be split in different processes.
Yes.
Now you mentioned for your daemon, your running process, that you're going to have multiple threads going. What are your favorite patterns, like actor pattern or background worker? How do you reason about that? How many independent things you have going on within that one worker process?
So I would be thinking about it maybe in the case of the daemon, you're really thinking maybe more about kind of agent-oriented programming, which is, I don't know if that's an older name for actors, but it's pretty similar to the actor in other places in Wolverine itself, where to me, what I was calling an agent would be something that's more or less independent in the process. It could be a background service in an ASP.NET Core application that's running something on a timer or running continuously.
Yeah, the service workers.
Something that has a little bit of that stood up independently, that is maybe producing work for the downstream queues. So it does turn out to be a lot of producer-consumer, but the agent approach, anything you need to do on timers are scheduled. That's something I like. Now, that's far short of complexity for a full-blown actor system, like something like Akka.net.
Yeah. Well, that makes a lot of sense just from factoring the different logic, a piece of code that figures out what work needs to be done and then dispatching it to various places, and then other bits of code that are more single purpose that just take the incoming work and just crank it out.
Yes.
Nice. Now, how much to implement that pattern? How much do you futz around with threads, or how should developers think about that? Because every time I've done thread work, I've backed away and said, is there a way I can do this without thread work?
Yes. So it's the rule that we've heard all our career. You should probably have some basic understanding of one level underneath you, but I don't think you necessarily want to work on the thread level yourself. Okay. So even using Wolverine and Marten and all the parallelism in there, at no point am I doing any kind of starting a thread up myself.
Okay.
So look at higher level libraries. So I mentioned the TPL Dataflow. That's a great library for parallelism and limited data streaming. There's also RX.net, the reactive extensions for .NET. That's more data streaming and transformation, but that can give you a little bit of parallelism. Definitely understand the task parallel library inside of .NET, which is still, it's one level up from pure threading, but there are a lot of gotchas in that. The basics are pretty easy. Getting more advanced, and you probably need to invest a little more time in understanding some thread pool issues. It's no matter what we say here about the tools that make it easier, it's not an area that you need to take lightly. It's not something you should just, I'll do this for fun to make my application faster.
Yeah. Okay. All right. So we're on the same page. We shouldn't be starting up new threads in our own code.
Probably not. Not unless that's something you do every day and you're good at it.
Yeah. not if we're building applications.
Correct.
Yeah. So I want to kind of spread out a little bit. You've done so many different things, structure map, Lamar, Marten, even, acceptance testing tools and whatnot. What are the, the current projects that Jeremy Miller is working on right now that other people might find useful?
So most of my time right now is Marten or Wolverine. So it's, the critter stack. And we purposely
define critter stack too.
Okay. So we have a family of tools. It's JasperFx organization on GitHub. So originally started with a naming convention of everything was named after a small town around where I live. Mm-hmm. Jasper itself is my hometown, right? Just the way Microsoft names their yeah. So it's little tools. It's the successor project to structure map, the successor project to FibOVC. Marten was something different. Told the story way too many times, but Marten was originally built to replace a very, very early version of RavenDB that we were having trouble with at my company at the time. Mm-hmm. So my boss calls me one day when I'm well into the POC and asks, what are you going to call it? You are going to give it a really boring, lame name like exactly what I was calling it at the moment. So I said, no. And as fast as I could, I Googled, what are the natural predators of ravens? And the little Marten guys apparently will steal raven eggs. So we call it Marten. Marten it looks like a weasel. It's really closely related to weasels. Wolverines are in the same family. Mm. So Marten is our document database and event store. But if you're using an event store, you're probably not, you don't have to, but you're probably using some kind of CQRS architecture as well. Mm-hmm. So there's a lot of things that go with it. How do we stream events? How can we listen to events and stream them to message handlers that may take other work? Do we stream it across applications? Building command handlers in front of the event store that can do things like concurrency protection, optimistic concurrency. So Wolverine was kind of rebooted to work very closely with Marten. To be more of a full end-to-end stack for server-side development with event sourcing and CQRS. Mm-hmm. We'll also throw in asynchronous messaging, and just to make everything bigger, it's also an alternative HTTP API library.
Okay.
So that, and there's some smaller supporting projects underneath it. Command line processor called Oakton, a web API testing helper called Alba, and Lamar, you mentioned that's the IOC container. But everything for me right now is the critter stack.
All right. So where can people find the best maybe reference implementations just to see what's there and how they might use it?
So have quite a few samples on the websites for both applications. You can find everything from the new company website, JasperFx.net. That'll link to everything, or martendb.io for just mm-hmm. Marten itself. Wolverine, right now, WolverineFX.net. And both of the documentation websites will point the way to a lot of samples.
Awesome. And I think you're going on almost 20 years of IOC container author, just as one example.
Right there. So make you feel old here, Jeffrey. So you remember my son Max that might have been around the data cert office.
Yep.
So I started Structure Map in the summer of 2003. And went in production in 2004.
Yep, 20 years.
I started it just before Max was born, and Max is leaving tomorrow for his sophomore year of college.
Nice.
So yes, I'm right at 20.
Which means that you are one of the small handful of dependency inversion experts out there in the .NET industry, having not only authored one, but authored one that's been used widely, and then for 20 years, and of course the .NET Core and .NET 7 version, you kind of redid it into Lamar. With all that perspective, what is your view on IOC, brand new application developers? What should they use? What are the core patterns that they should be doing, and what may be noise that they should just kind of stay away from?
So I think you're absolutely fine to start with the built-in DI container. Lamar and others will add more functionality. The biggest thing they add is better diagnostics. That is the one single biggest reason to use Lamar over the built-in container. But starting with the built-in, that one's fine. The biggest thing I think folks actually need to understand, structure injection at the beginning, just that something else is stuffing what I need in. Understanding the life cycle. What's the difference between something that's scoped and something that's a singleton or a transient? Understanding where and how the IOC container is disposing of resources for you. That's the single biggest thing I see is when people actually don't lean on an IOC container and try to take the disposal into their own hands. That's when especially newer developers, or just a developer like me that hasn't been gotten fully awake in the morning, that's where you get yourself in a lot of trouble. Just understanding, how does the IOC clean up behind you?
Mm-hmm.
From there, the single biggest piece of advice I would give after that is use an IOC tool, use it pretty simply. Maybe actually don't bother with a lot of the very advanced IOC stuff. Try not to do very much runtime logic inside your IOC tool. Think to yourself all the time, if the system is going to be much easier to understand if you build a little bit of explicit code inside of your application versus doing some complicated configuration of the IOC tool, write some explicit code and don't even think about it again.
Yeah. So am I overstepping to say if you're using whether the built-in container or Lamar, you find like a page and a half, 2 pages of, for this interface, use this interface, but scoped, but with these parameters, and that code just goes on for several scrolls, that maybe that's a little bit too much?
Maybe, but that could be just telling you your system's too big. That's a longer conversation of keeping your call stack shorter.
Mm-hmm. Gotcha. Well, the list is definitely short of dependency inversion experts like you who've gone to that level. So I appreciate that perspective. Before we go, can I ask you to plug your company? Because that's you started a company and y'all are looking for customers. Well, tell us, what do you do, and who are you a good fit for?
So we are. So I have a couple collaborators, Oscar Dudas in Poland, Babu in India. I mean, we have a real core team, but right now, so we are trying to build a services model for support contracts and product add-ons for Wolverine and Marten. So that's the longer term. But right now, we are also a straight up consulting company. So regardless of what your stack is, we're all kind of experts on .NET. The other guys have done more Node.js type work than I have. But if you want architectural reviews, we help you with that. Any kind of modernization efforts, that, oh my gosh, I have this humongous legacy system. We can't throw it away. We'd really like it to be on newer, stiffier stuff. We can help you with the long-term planning of that, incremental steps. Help you with asynchronous messaging, because that's very complicated. Event sourcing is very new. We can. There's not a lot of books. There's not the Gang of Four Martin Fowler books on it, and unfortunately that's a real problem. Or you finally want to get some help with test automation, or have your teams learn test-driven development. If anything like that sounds like something you would want some help with, JasperFx, we're it's just thinking of the Ghostbusters movie when they had the silly little ad. Do you have paranormal activity? We're open for business.
Yes. Okay, I made my kids watch that original movie, so they know that as well.
Nice. So the Ghostbusters movie, this has been about 10 or 15 years ago. That's when I knew I was starting to be one of the older developers around, when I dropped a Ghostbusters reference to some developers I've worked with, and they had no earthly idea what I was talking about.
Right. Well, when the new when the new movie comes out, we say, whoa, you want us to take you to theater to watch that movie? We're going to watch the ones that came before.
My younger son doesn't have a lot of patience for movies, but he's watched the Star Wars movies with me, and he's watched the original Ghostbusters.
Yeah.
That's about it.
Yeah, Matrix falls into that category now with the late, the new Matrix that came out, and because those go back almost 20 years, right? Somewhere around there.
No, they're older than that. I think the first one was in 99.
Was it in the 90s? Yeah, before my kids were born. So, well, Jeremy, thanks so much for coming on the Azure DevOps podcast and talking with us about parallelism and a lot of other topics that you've kind of, waded through the swamp and come out victorious. I appreciate your time.
Thanks so much for having me, Jeffrey. And it was good to catch up.
Yes, sir. Yes, sir. My pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.